Alright, so welcome to week 12. Week 12 of the CNTL3020 26 Winter Controls 2, Fanshawe College, London, Ontario. And today is April 1st, 2026. Alright, I can see people rolling in already. Okay, cool. Alright, so here is the scenario that I'm going to give you today. The challenge is to make a system, a pneumatic system, that is connected to PLC and we are utilizing two momentary, normally open push button switches. One switch is supposed to make that pneumatic cylinder, double acting cylinder, oscillate by pushing that push button momentarily. And if we push the other push button momentarily, it's supposed to stop the oscillating of the cylinder going back and forth. And all the logic is supposed to be happening at the PLC level. So two push buttons, one starts the oscillation, one stops the oscillation. Alright, so two things we're going to review quickly, and then we're going to put them together, put them to work together. Here is something that we already know as 3-wire latch. What happens here? And this is the PLC logic, the ladder logic right now. So if we have one instruction, XIC here. Another instruction that is also XIC, examine if closed. And we have OTE, output energize, and that's it in this ladder, in this rung that we have. What is going to happen if we assign this little guy to a push button? Assign this little guy to a push button. Whichever it is going to be. Let's say push button 0. So of course that is assigned to the input 0. We're going to, we're just going to assign that like that. This one here, we're going to assign that to output, let's say 9. I just picked that number out of thin air. And we're going to drag and drop the tag into this instruction right here. So this is going to be also tagged as output 9. And in the tag description, in the tag window, we can write our own description here. We could just we could call this one a pilot light 17. And we could call this one something else. Let's say pilot light 17 hold. Okay. And of course, just as a review of this, press the push button, give it logic 1, and of course the examine if closed, logic 1, passes the logic through, it is going to activate the output, and if the output is tied to this hold instruction, the hold instruction is going to keep the logic through, so then we can release that button and the logic is going to go through, so this thing is going to be stuck on, will be latched. So this one is a 3-wire latch, wire 1, wire 2, wire 3. Coming out of it, wire 1, wire 2, wire 3. 3-wire latch. Alright, the problem with this one, as we know already, is that once we push that button and we release that, that thing is going to be stuck in the on position. And that's it. We are latched. So what we could do is add one more instruction here. Just clean up a little. So we get the same thing here. We have ourselves a start button. We have ourselves a stop button. And we have a hold button that is synchronized with the output instruction. So now we have two push buttons. Here we have a push button, and notice this push button here is a normally open push button. And over here also we have normally open push button. So here is the start. Here's the stop. Here's the hold. And here's the output, and we are going to call that on. We just named it on. And this is as a tag. And we just call it here, and okay. Notice that I'm just going to change the colors of my pen. When this button is not pressed, that instruction is passing the logic through. So the button is not pressed, the logic is passing through because this is an examine if open instruction. Once we press this push button, we're going to activate this whole thing. So this is going to pass the logic through. It is going to activate the output, and since this hold instruction, which is not an alias to any of the physical terminals, it's an internal bit, it is going to light up as 1, and if we release that button physically, we still have the logic going through here, so we are latched in the on position. In order to unlatch this, of course, we're going to push this button, and because this is examine if open and it's looking for logic 0 to pass through, and it's getting it, but when we push that button, we're going to apply 24 volts to the terminal that this thing is assigned to, which is going to give it condition that is going to make this rung false at this point. And so if this rung is false at this point, the whole rung is false. So that is going to turn off, and that is going to turn off. So we have a start button, momentary activation, and stop button, momentary activation. So this right here, we call this a, well, maybe I can just put a text here. Cancel that. No, not cancel that. Changing the colors. Where are we here? Text. We have 3 3-wire latch. Yeah, okay. Three-wire latch. Okay. Now, let's have another scenario here. I just activated this graphics here. Let's just, for now, let's make these two instructions examine if open. Just for now. Later we're going to change it back. Here and here, which means that the logic is passed. So these two rungs, this rung and this rung here, they are active now. And if we assign this instruction to a push button, and we assign this instruction to a push button by assigning them to physical inputs, what is going to happen? We activate this instruction. It is going to make the rung true, and this output is going to get logic level 1. As soon as we release that button, this rung becomes false, so we're going to have logic level 0 here. So we're not there with this. Right? But instead of having the output energize, OTE, if we choose another instruction here, and this is going to be output latch, and we can make this one output unlatch, so that's a U. Alright, now we're getting somewhere with this. Okay, come on, it's getting stuck to my mouse today. Alright, so when we activate this instruction, this output, wherever it is assigned, is going to latch on, because that's the instruction, the software instruction, instead of just output energize. Press that, and then once you press it, this is going to latch on, and no matter how many times you press it, it's not going to make a difference. This thing is stuck on. All right. So if we assigned this, if we make it an alias for, let's say, pick an output. Let's say this is going to be alias to output 7. And if we assign this instruction to the same output terminal, physical output terminal, output 7. Well, now we got something here. We press this instruction, we activate this instruction. It is going to turn on output 7. And it's going to stay there. That output 7 is going to jump up to 24 volts, and the output is going to stay there. And no matter how many times we press it, that thing's going to stay. But if we have another push button assigned to another input, we press this one activates another instruction, which is unlatch. And since it's assigned to output 7, because we just assigned that to output 7, then it's going to turn off output 7. It's going to stay there no matter how many times you press that. So we have a latch, and we have an unlatch system here. All right. In this case here we have latch, unlatch, latch. Okay? Alright. Can we make those two work together? But before I do that, I'm going to erase those markings here. Now we have all of these 4 instructions, they're examine if closed, XICs. We have 2 push buttons, physical push buttons. Excuse me. And that's it, because the request was to have 2 push buttons. And they're the same, XICs. Sorry, not XICs. Normally open push buttons. One is assigned to an XIO instruction, and one is assigned to the XIC. So this one starts, this one stops the system. Alright, why did I put 2 instructions in series here? So it's like having 2 AND gates. See that? It's just like having 2 AND gates. Alright. Let's say we assign this guy right here to the same bit. So we could just drag and drop the tag into here. And again, we're going to drag and drop the tag into here. So this is going to have the tag of on, the name of the tag. So here's on, and so is this one. What do we accomplish by doing this? All right. Let's get the green color here. The system is on, the rails are activated, system is in the run mode. So by default, this instruction is passing the logic through. It's making it true. Which means if we do something with this instruction, something is going to probably happen. What is going to happen? Well, let's say we push this button here, so we're giving it a logic 1, which makes this run through true, and this on bit, which is not assigned to any of the physical terminals, but we have that bit in the memory that also this guy is looking at, so we could follow it, and this guy is looking at. And since this one is latched in the on position, and this guy is following that, and so is this one, then they both are going to become true. See what we are accomplishing by doing this? Over here is just like having an AND gate with one of the inputs stuck on, so whatever we do to the other input, that's what the output is going to be. So by turning the latch on, we are making these two rungs active, ready for action. And these could be our control instructions. Right. We're not there yet. We're not at the end of the road yet. So, since we have acted, the purpose of this 3-wire latch is to activate this rung and this one, so they're active. Since they're active, if we press this button now, we are assigned this thing to output 7, so output 7 is going to get latched because we have the output latch instruction here instead of just output energize. So that is going to get latched, and then no matter how many times we keep pressing this, that thing stays latched. Until what? Until this one is activated, and this one, activation of this little guy, is telling output 7 to go low, to unlatch, which means go low and stay low. No matter how many times you press this, until that one is pressed, and then that one is going to tell the output to go high and stay high, because it's a latch. Alright. We're getting somewhere with this. Now take a look at this. We have this little guy here, and we have this little guy here. Here's a double acting cylinder. Here's a 4-2-way valve actuated by solenoid on one side. What does the solenoid need to be actuated? It needs to have 24 volts applied to it. And when it does, it shifts the position. And when the voltage disappears, the spring pushes it back into the resting position. All right. So let us connect those air hoses. If we connect this one to here, and we connect this one to here, these are the air hoses. Here's the air supply, so you can see that's a pneumatic system. When this thing is sitting at its resting position, then this valve is passing through the air, pressurizing this chamber, and this chamber has pressure in it. It's pushing the cylinder back, so this is a retract position here. And when we activate the solenoid, this valve shifts and it switches the ports, so that port is going to be active with the air. You see that here? We're going to pass through here. And this chamber is going to pressurize, pushing the cylinder out. All right. So let's call this solenoid, be sort of professional here. Let's call this solenoid Y1. Now, since both of these instructions are tied to physical output, number 7, well, we can connect that physically with wires here. That output 7 can be connected to this solenoid. So we could put a description on this here, just so for ourselves here. Here's Y1, and so is this one, Y1. See that here? Now, we're getting somewhere further here. What happens? We activate the system. Press the start button here. That activates, and this one's already active. This goes 1. These 2 are following it, so those rungs are active. So now what happens to the solenoid depends on these 2 instructions. If we activate this one, solenoid is going to get stuck on high and stay there until we activate this instruction, which is going to make the output number 7 go low and stay low until that one is pressed. So a quick question here. We have 2 push buttons over here. We got the start button, we got a stop button. The start button just activates everything, turns things on. The stop button just deactivates, so no matter what we do here, nothing's going to be, so that this here is going to be, this little forward two-way valve is going to be stuck in the resting position. What can we do with these? Any idea how can we utilize these 2 instructions to make the system oscillate, go back and forth? Can anyone have any idea here? I'll give you a few seconds to maybe see if somebody comes up with some sort of idea. All right. Okay. Matthew. Latch rank should be connected. Start and latch should be stop. Which one? You can go on voice if you want. Go ahead. If not, I'm not sure I'm following you here. Latch rank should be connected to start. Oh, hold on. You mean this one connected to start and unlatch connected to stop? Question mark. No. That is not going to help us. Are they on as well? These, you mean these two? Yeah. No, well, they're just sitting, waiting to be instructed to either go high or low. So at this point, right now, they are sitting at low. All right. Thank you for participating, and yeah, we get less people in this group, but more participation. All right, cool. I like it. All right, so here's the idea. We'll make this one a switch, and we make this one a switch. We can assign these to physical input, one of the physical input, and we can assign this one to another physical. So these could be assigned to physical inputs, but not necessarily push buttons, because we already have, we just said we have to have two push buttons, that's it. And we want to make this thing oscillate. All right. So why don't we do this? We call this one here switch 1. We call this one switch 2. Okay. Right here and right here. Switch 1, switch 2. An idea what kind of switches they are? These two guys? Remember from previous labs? Limit switches! There we go! Now we're driving this one home. So this limit switch here, and they are normally open limit switches. So when the cylinder activates physically the arm of the limit switch, it momentarily closes this one here. So what happens? This is retracted. This one gets activated, sends the signal to this little guy right here, and it latches. What does it latch? It latches Y1, which is here. And since it's latched, it's going to have constant power applied. So that is going to shift, and the cylinder is going to start extending. Once it extends, it's going to release that switch, but it doesn't matter because this is latched. It's going to travel until it hits the second limit switch, and it's going to activate that, and it's going to send the instruction to the same output, which is connected to this guy here. It's going to tell it to unlatch, which means go low and stay there. Once it goes low and stays there, that solenoid is going to be deactivated, so this valve is going to be pushed by the spring to its resting position. So now this port is going to be active, pressurize that, is going to go make it go back. Once it goes back, it's going to hit this switch, activate again, it's going to extend. Hits that switch, it's going to retract. Goes this switch, going to extend. And it's going to go back and forth because these ranks are active until you press this little guy right here, which means it's going to unlatch this base right here. This is going to go 0, and so is this one, and so is this one, and nothing's going to be happening here. So the system is going to stop oscillating. Over here, you could see there are two AND gates. I'm just going to draw this. Hope you can see it. Like this rung is just like an AND gate. And if we have this switch on, it's just like one of the inputs is stuck. One. So whatever is on the output is what this one does. And so is this one right here. Now, the final piece of this puzzle, how do we connect that? Just to make it recreate the ball. I just call this one a diagram. It's sort of the EMA, sort of the electrical diagram. Alright. What do we have? We could call this push button switch 1, and we could call this switch 2. Sorry. Push button 1, push button 2, so we could call this one start. And this one we're going to call stop. Alright. So we can assign this to physical input. Let's say 0. And we can assign this to physical input 1. Let's be consistent. So here's the start. Input 0 here. And stop. Input 1. Here's the assignments. This one is not assigned to any physical outputs, but it serves the purpose of activating these two or deactivating these two. That's all. So it's internal through the software. Alright, so we have these two solved. Now, here is a limit switch and here's a limit switch, and they're both normally open. Yeah, that's fine. So we could call these guys here. Here we can call it switch 1, switch 2. These are these two switches. And this would be right here, that would be the ons. So we're going to leave them for now, but we still have to assign them to a certain input number. So we could assign that input 2. We could assign this to input 3. I just keep going with those numbers. So we have those. Yeah. These will be the limit switches here. And over here, this is the solenoid. And this little guy here is the output. Seven, which is that one there. So here are the assignments. Because with those here, we still have to. This is a physical switch, but it still has to be assigned somewhere. So these are those. See, these are the physical switches that are mounted on the board. These are these two. And these two this one is actually this one here, and this one is actually that one there. This will be the physical terminals. So now we have the logic figured out, and notice the logic is happening all in the PLC. That's the whole point of having a PLC. And over there we just have a bunch of normally open push button switches. By momentarily activating them, one starts the whole oscillation, the other stops. So this is a 3-rung system. We couldn't do this with those two push buttons. We couldn't do that with just 1 rung. So let's just go from the beginning to the end here, what happens as far as the action goes. Erase those. Okay. So we start the action. If we press this button here, system is retracted, so that switch is being pressed, limit switch is being pressed. Is anything going to happen? No, because this one is not on. Why is it not on? Because this one is not on. Why is it not on? Because the start button wasn't pressed. So nothing happens. Because those 2 rungs are not active, because the latch is not latched. Alright, let's press the push button, the start push button. We press this one. Now, that one is by default. It's passing the logic through. We pressed that one. This one lights that. And if this one lights, then these 2 switches, or these 2 instructions, automatically become on. So now the rungs are active. So we just activated the rungs. And now if we erase, if we depress that, we already have, I haven't drawn that here, because this output, it's not physically connected to anything, but it plays an important role. This output activates that, so it latches, but it also activates these 2. And then Now this thing is activated. All right. System is retracted, so this switch is being pressed. So this instruction becomes true. It latches the latch on. It applies 24 volts here. System system extends. Right. Then once the system extends and reaches this point right here, then this little guy here activates. This little guy activates, unlatching the output. Output goes down to 0 volts. We got 0 volts applied here. This valve goes back to the resting position, and the cylinder retracts until it hits this button, because once it retracts, it's going to release that. It's going to be open again, but it's because it's unlatched, and when it unlatches, system still waits for another instruction. It's going to hit this switch. It's going to press that. This thing is going to activate. Output is going to latch until it's going to oscillate back and forth. And this is how we do this 3-rank system. That's how we interface ranks together. We interfaced two types of latches together. And we can do it that way. All right? Why don't you just watch this thing maybe one more time, or when I post these notes, you can just look at it and remember what we're talking about, and you can watch the video again if you need to. Because on the lab test, maybe I'm going to give you that task to accomplish, but with no notes. You're going to design the whole system. So the systemicity of this thing would be: create a 3-wire latch, create a latch and unlatch latch, and you have to understand that the purpose of the 3-wire latch is to activate those. How do you activate? You just give those 2 instructions to make an AND gate, just like that. This guy here activates these 2 when it goes high. And then once this thing is active, these 2 are active, then whatever we do to this switches is going to make a difference. And here's the key idea of this. This is where those 2 latch and unlatch instructions are tied to the same output. Activating one latches that output, and activating the other one unlatches the same output. And if that one output is connected to a solenoid of a valve, it is going to, when it activates, it's going to push it one way. When it's deactivated, it's going to release that pressure, so it's going to go back to the resting position, and that's how we can make that oscillate. All the logic is happening at the PLC, and we have those 2, the same kind of push buttons that are momentarily activated. All right, we got through this logic here. You think you can do this thing on the lab test? I think you can. Special thanks to Miss Tomaszewski, who came up with the idea of giving you this task. Cool. That's it for tonight. Enjoy the rest of your evening. We are coming to an end of this semester, so just a little few steps and just think about it. You're going to have 2 weeks break. We're almost there, but don't slow down yet. Just make those few last steps to finish the whole thing. We're almost there. All right. Thank you so much for showing up. Thank you for your attention. Thank you for your participation. And I'll see you tomorrow during the labs. Goodbye. Good night.